half-angle identities for sine and cosine on the board. What I want to do now is use those to derive the half-angle identity for tangent. And sort of like the double angle formula for cosine, this one's actually going to have three different forms that we can use. I'm going to just start by saying that tangent of a over 2, I know is just sine of a over 2 over cosine of a over 2. So since I have a formula for sine and cosine of a over 2, I can certainly find a formula for tangent. So it's plus or minus the square root of 1 minus cosine of a over 2, and I'm sorry, that square root extends across that whole fraction, all over plus or minus the square root of 1 plus cosine of a over 2. Now, I've got a plus or minus on top of a plus or minus. Well, that's going to either be positive or it's going to be negative. There's no need to write a plus or minus more than once because there are only two options. It's either going to end up being positive or it's going to end up being negative. Now, I know that I can write this all under one big square root because square roots do distribute over multiplication and division. So I'm going to get 1 minus cosine a over 2 all over 1 plus cosine a over 2. But now that I have that fraction all under the square root, that's just a fraction divided by a fraction, and I know that I can flip and multiply. So this is going to be plus or minus the square root of 1 minus cosine a over 2 times 2 over 1 plus cosine a, and those 2's will cancel. So I'm going to get plus or minus the square root of 1 minus cosine a over 1 plus cosine a. Now that is a fraction underneath a radical sign, so anytime I use this formula, same with these. These are fractions underneath the radical sign. Anytime I use that, I'm going to have to end up simplifying so that I don't have a fraction in the denominator for my final answer, but this is the formula that I will plug into. Okay. So that's the first version that we get for tangent of a over 2. So let me just copy that over here. That's going to be plus or minus the square root of 1 minus cosine a over 1 plus cosine a. Okay, that's the one that I think is the simplest to derive because it falls directly out of just the quotient identity that tangent is sine over cosine, and then the half-angle formulas that we have for sine and cosine. Okay. It turns out, though, that I can simplify this a little bit, and there are two that are actually a little bit more user-friendly in terms of how to use them, because we can eliminate the roots and we can eliminate the plus or the minus, which is kind of amazing. Okay. So I'm going to just notice that this is plus or minus the square root of 1 minus cosine a over the square root of 1 plus cosine a. And I have two options for simplifying this. One is to multiply top and bottom by the square root that I have on top. The other is to multiply top and bottom by the square root that I have on the bottom. It's not obvious why either one of them is useful, but let's take a look. If I were to multiply by 1 in the form of root 1 minus cosine a over root 1 minus cosine of a, notice I'm going to get this plus or minus. Now this will be the square root of 1 minus cosine of a squared. And on the bottom, I'm going to get the square root of, now this is going to be a little bit different. 1, the outsides and insides cancel, minus cosine squared a. Notice the difference. On top, I'm subtracting 1 minus cosine of a and squaring that, because I've just got two factors of that subtraction problem. On bottom, I'm squaring cosine of a and then subtracting that from 1. Okay. So we've got a plus or minus the square root, well, actually, I can go ahead and simply say that's going to be the absolute value of 1 minus cosine of a. right? Because anytime I have a variable quantity and I square it and then take the square root, I get the absolute value of that thing. Over, now I can use my Pythagorean identity and say this is going to be square root of sine squared of A. Okay, so I'm going to just bump up to the top of the board so that I've got some more space. So what we have so far is tangent of A over 2 is plus or minus the absolute value of 1 minus cosine of A all over, and the square root of sine squared I can say is the absolute value of sine of A. Okay. So I do have these two absolute values here, but we've got something very interesting. 1 minus cosine of A is always bigger than or equal to 0. There's no way that can be a negative quantity, because the biggest cosine can be is 1, and 1 minus 1 is 0. And if cosine is smaller than 1, 1 minus anything smaller than 1 is going to give me something that's positive. So the quantity inside the absolute value here is never negative. And when I take the absolute value of something that isn't negative, the absolute value of 5, that's just 5. If what's inside the absolute value isn't negative, I evaluate the absolute value by just taking that quantity. So I can say, okay, this is plus or minus just 1 minus cosine of A. I've evaluated that absolute value over the absolute value of sine A. But now I know that this top part is not negative. So whatever sign I put here has to match the sign of tangent of A over 2. And there's a nifty fact, and that's that the sign SIGN, the plus or minus sign of tangent of A over 2, always matches the SIGN, the plus or minus sign of sine A. So I'm going to, I've got plus or minus the absolute value of sine A here, but if I dropped the plus or minus and the absolute value, I would just have a sine A on the bottom. The top here is never negative, so the sign of this fraction is going to be determined by the sign of the denominator. I want it to match the sign of tangent of A, and it does. So it actually works out brilliantly that tangent of A over 2 is just 1 minus cosine of A over sine of A. That does rely on using this fact, because as I simplify things, I'm getting a plus or minus and an absolute value, and I have to just know that the signs of these two things are always the same. Now, that's not something that I expect you to have memorized. So, on an exam, if I ask you to derive a half-angle formula for tangent, you're allowed to just derive that one. That's the one that falls out directly from the quotient identity for tangent and the half-angle formulas for sine and cosine. Okay, so I would not expect you to derive this formula or to derive the other version of the formula that we're about to take a look at. But it's kind of nice to know them, because this is a lot more user-friendly than this version, because this version doesn't involve me having to take any square roots, and it doesn't involve me having to decide which sign things should be based on the quadrant that things are in. Okay, so that's a pretty nice version of things, since I will be allowing you this semester to use a formula sheet on your exam. I should qualify that. This is, I'm talking about spring of 2020, okay? Now, it's possible I'm going to use these videos in a subsequent semester as well. If it's not spring of 2020, check with me about whether you're allowed a formula sheet. But spring of 2020, you're allowed a formula sheet on the exam. I would encourage you to write that formula down. because I do think it's tricky to derive it because it relies on this fact about the signs of things, but it's more user-friendly than this one. Okay. All right. So I said there was a third version of this. And so I'm going to start once again with this, that tangent of a over 2 is plus or minus the square root of 1 minus cosine A over the square root of 1 plus cosine A. That's just this formula distributing the square root over the top and the bottom. Now what we did last time is we multiplied by 1 in the form of what we had on the top over itself. This time I'm going to multiply by 1 in the form of the square root of 1 plus cosine A, the root that I have on the bottom over itself. So I'm going to get plus or minus. On top, I'm going to have the square root of 1 minus cosine squared A. Because again, outsides and insides will cancel, and when I FOIL, my first terms are 1, and my last terms are minus cosine squared A. On the bottom, I'm going to have the square root of 1 plus cosine of A, quantity squared. So that becomes plus or minus the square root of, again, sine squared A over the absolute value of 1 plus cosine of A. But this is always going to be bigger than or equal to 0. Because the most negative cosine of A would be negative 1. That's the smallest value cosine can take on. That would make this 0. Now, obviously, that would make the fraction undefined. Okay? But if cosine of A is bigger than negative 1, and I add that to 1, I'm going to get something that's positive. So I can say the bottom's just going to simplify to 1 plus cosine of A, because that quantity inside the absolute value is never negative. The top is the absolute value of sine of A. But once again, I can use that fact that the plus or minus sign of sine A has to match the plus or minus sign of tangent of A over 2. So I can actually say this is just going to be sine A over 1 plus cosine of A. Because the denominator here will be positive, so the plus or minus sign of this will match the plus or minus sign of that and give me the correct answer. So the third version of the formula that I have is that tangent of A over 2 is equal to sine A over 1 plus cosine of A. Now, these two versions I think are the more user-friendly, but this is the easier one to derive. So again, if I ask you to derive a half-angle formula for tangent, you are free to derive that one. I will not hold you responsible for deriving these two, but I think they're easier to use, so I'd encourage you to know them and in spring of 2020 to put these on your formula sheet so that you'll have them for the exam. All right, next video we'll practice using them.